Welcome to our class once more, and we want to start with set applications. How do we apply sets? In our previous classes, we dealt with sets. So we want to now do some applications of set. So we'll first start with a set application that involves two diagrams in terms of two items. So let's consider a diagram that has to do with set A and set B, considering two distinct sets. So if we draw a Venn diagram is a pictorial representation of any given set. So whenever we want to show the picture of a set, we normally use the Venn diagram. Now, so we draw this Venn diagram and draw two cycles within the Venn diagram. Now, the Venn diagram can be a rectangular shape, or square shape, or even a cycle, whatsoever the case might be. Yeah, so it is not only a rectangular shape that is used to indicate a Venn diagram. So we draw two cycles within this Venn diagram, and we named the various regions in the Venn diagram. So we call this region, region 1. This whole portion, we call it region 1. We call this region, region 2. We call this region, region 3. We call this entire region that is outside region 4. Now, what is region 1? We said region 1 is denoted by A intersect B prime. Now, what does that mean? This is set A. This whole thing is set A with the white cycle is set A. So this set A now has intercepted set B. But whenever you say B prime, it means all of those elements that are in the universal set but are now within B. So because we only want to indicate this portion, we only want this portion, we only want to name this portion and not to include set B, we add B prime. So B prime means this cycle is not part of this particular region, which is region 1. Region 2 comprises of both the intersection of A and B. Where A and B meet is region 2. So that's what we have that region 2 denotes A intersect B. Region 3 is denoted by A intersect B. But we do not want to include set A, so we attach prime to set A. So we say A prime intersect region 3 or intersect set B. So it's A prime intersect B. A prime are all of those elements that are within the universal set but are not found within this cycle. So because they are not found within this cycle, they are referred to as the complements of A. So that's why we say A prime intersect B, because we only want to indicate right here, just this portion here. And then the last portion, which is region 4, we have the entire outside portion. And it indicates those who are not found in A, neither found in set B. So we say region 1 is only A. So region 1 is only A. Region 2 is both A and B. Region 3 is only B. And region 4 is neither A nor B. So we say mathematical expressions connecting the various regions in the Venn diagram include the universal set U is equal to this entire diagram. Everything within this diagram represents the universal set. So we say R1 plus R2 plus R3 plus R4 give us the universal set. Now the number of U, so the number of elements that are found within U comprises of the number of A union B, when you put A and B together, so it will include these two cycles, plus the number of A union B all prime. So we know that A union B comprises of these two cycles, but A union B all prime are all of those elements that are not in these cycles, but rather outside of the cycles. So those that are within a cycle, those that are outside the cycle, when you add them together, it gives you the universal set. Now, what's about finding the union of set A and set B? To find the number of elements within A and B, we find the number of A plus the number of B, then we subtract the intersection from the set. So we subtract this intersection, this center arrow 2. We subtract arrow 2 from the number of A plus the number of B. So let's look at some examples. So we have some example problems under applications of sets involving a two diagram or two sets. So the first one says, in a class of 60 students, 40 students read inquiries newspapers, 25 students read the newspapers. Each student read at least one of the newspapers. Illustrate the above in a Venn diagram. How many students read both the inquirers newspapers and the newspaper? And how many students read only the inquirers newspapers and only the newspapers? So the first thing we do is that we collect our data. Now, in this entire problem, we cannot continuously write newspapers, inquirer newspapers. We must represent them with some variables. So we could say let. Now, we are dealing with two sets, inquiry newspapers and that of the newspapers. So we could say let A, depending on what you want to represent it with, we could say let A equals, or let A represent the inquirers newspapers. And we could say let B represent the newspaper. So now we have A representing the inquirer newspapers and B representing the newspaper. Now, the next thing we know is that we have a total class of 60 students. So 60 represents the universal set. So we have the number of U is equal to 60. The next thing we have 40 students read the inquirer newspapers. So the number of students that read inquirer newspapers that represents A is equal to 40. And also 25 students read the newspapers. So the number of students that read the newspapers that representing our B is equal to 25 students. So we say each student read at least one of the papers. Whenever you hear each student or each of those members of the various sets are part of one of the sets, it means that the number of people who are not part of other set is equal to 0. So because each of these students, they read out of the newspapers, it means the number of people who did not read the inquirers or the newspapers is equal to 0. So that is to say, the number of students who read the inquiry newspaper combined with the number of students who read the newspaper all prime. So this indicates the number of people who are not part of set A and set B. We say is equal to 0 because we say each of them are part of a single group. The next thing we know is that each student read at least one of the newspapers. Okay, so those were the information that were given to us. Illustrate the above in a Venn diagram. Question 2, how many students read both the Inquirer's newspapers and the newspaper? So, how many students read both newspapers? It means the intersection of A and B. So we say A intersect B is equal to some unknown variable X. How many students read only Inquirer's newspapers? So from the explanation, from the beginning we told you, when it is only a particular set, like only Inquirer newspapers, it's like the intersection of A intersect B, then we say all prime or B prime, because we do not want to include B. We only want to know those students that read only this newspaper. So there is also equal to question mark. And also, how many students read only the newspapers? So A is not part of it, so we say A prime intersect B, because A is not part of it. It's also a question mark. So let's come on this side now and draw a Venn diagram. So we draw a Venn diagram. And then we have the two sets placed within the Venn diagram. So, the universal set, which is U, let me bring this thing down a bit. The number of persons we are dealing with, which is U, the universal set is just equal to 60. So this cycle now represents the number of people who read, the number of students who read the Inquirer newspaper. So we say number of A, let's write it smaller. Number of A now is equal to 40. And this side, number of B, let me increase this thing. Number of B is equal to 25. Now, this intersection, those who read the newspapers and that of the Inquirer newspapers was unknown. So we represented it by X. So we say let this be X. Now mind you, those students who are part of set A, the 40 students, they are also part of, some of them are also part of the intersection. So in order to get the portion of students who are only reading or only read the Inquirer newspapers, it means we must say 40 minus X. And also, if we want to get the number of students who only read the newspapers, we must say 25 minus X to only get this portion. Because this whole portion here is 25. So if you extract this portion from there, which is X, this portion should be 25 minus X. Now, what's about those people who did not read either of the newspapers? The question did not say a student did not read either of the newspaper, because they said each student read at least one of the newspapers. So this portion, the number of A union B or prime is just equal to 0. So now let's find the number of students who are reading both Inquirers and that of the newspapers. Now, this is 40 minus X plus X plus 25 minus X plus 0 all equals to 60. Now, why did we do this? Because we told you that in this Venn diagram, there are regions. Region 1, region 2, region 3, and region 4. So we said that the universal set is equal to the sum of the 4 regions. So that's how we got this. So we simplify. This is negative x, this is positive x, the two are they cancel. This is 40 plus 25 minus x is equal to 60. So 40 plus 25 is 65. Now we send this x across the equal sign, and we send this 60 on the side of the equal sign, so it becomes minus 60. 65 minus 60 is just 5. So it means that the number of students who read both the inquiry newspapers and that of the newspapers just equal to 5. So now to get the number of students who read only the inquiry newspapers now, we just say the number of students who is A, Roman number 3, A. It won't just be only the inquiry newspaper is 40 minus x. So that is 40 minus x, and we know that x is equal to 5, so it's 40 minus 5, which is just equal to 35. And B, only the newspapers, 25 minus x. So we know that x is 5, so it's 25 minus 5, and it is just 20. So to know as whether your answer is correct or not, you need to add all of them. So this is now 35, this is 5, this is 20, and then it's 0. So 35 plus 5 is 40, 40 plus 20 is 60, 60 plus 0 is the same 60. So everything in here is just equal to 60. That's how we got the 60. So let's move quickly to the next problem. In the next problem is read, the University of Liberia administered her first entrance and placement exams to 12,500 applicants for the undergraduate programs. Of said number, 4,500 applicants successfully passed the English exam, while 3,600 or 3,600 successfully passed the math exam, and if 5,200 applicants did not pass both the math and the English, how many applicants A, passed both subjects, passed only math, passed only English, and we should illustrate this in a Venn diagram. So let's erase this portion and solve the problem right here. So again, we collect our data. Now we are dealing with two sets. We are dealing with the set of students who passed the math exams and the students who passed the English exams. So, or the applicants that passed the math and the English exam. So we say let M equals applicants who pass the math exam, and let E equal applicants who passed the English exam. Now, so we continue, right? 12,500 applicants sat for the exam. So the number of U is equal to 12,500. 4,500 applicants successfully passed English. So the number of students that passed English is equal to 4,500. And then 3,600 successfully passed the math exam. So the number of students that passed the math exam is equal to 3,600. If 5,200 applicants did not pass math and exam, that is to say the number of students for the English combined union, the math, or pram, those who did not pass the English and who also did not pass the math, is equal to 5,200. So now the question is, how many applicants passed both exams? Meaning the number of students that pass both English intersect with math is equal to an unknown variable just represented by x. How many students pass only math? Only math, it means the number of students that pass only math intersect English prime. So you need to exclude the English from there. So we say English prime, it means only math. It's unknown. The number of students also that pass only English. So we say math prime intersect English is equal to question mark. And we should illustrate the above in a Venn diagram. So now to illustrate this in a Venn diagram, since we are dealing with two sets, we draw a cycle, or we draw a diagram and insert two cycles into it. So like we said, these cycles could be rectangular and they could just be anything, not only cycle. Okay, so we inserted two cycles into it. And then let me change this one color. So we call this the number of students that pass the English. And it's just equal to the English is 4,500. 4,500. And this side, the number of students that pass the math is equal to 3,600. The number of students that pass both English and math is just unknown, which is x. The number of students that did not pass English and math, which is in this region, E union M or prime is equal to 5,200. Now, so how many persons only pass English? We don't know, right? So we can say, let this be 4,500 minus our x, because this x is also part of this cycle. And then this side is 3,600 minus this x, because we only want to know this region. And this entire cycle is 3,600, so we have to subtract the center portion from there. So let's know now how many students pass only, let's say pass both English and math. So we say region 1 plus region 2 plus region 3 plus region 4 all must be equal to the universal set, which is 12,500. So we have region 1 plus region 2 plus region 3 plus region 4 is equal to the universal set. So what is region 1? Region 1 is 4,500 minus x plus region 2 is just x. Region 3 is 3,600 minus x. Region 4 is 5,200, all equals 12,500. So we solve for x now. This x and this x cancel. 4,000 plus 3,600 plus 5,200 just gave us, this is 4 plus 3 is 7,000, 8,100, 8,100 plus 5,200 minus x all equal to 12,500. So we add these two. 8,000 plus 5,000 is 13,000 plus 13,000 plus 300 is 13,300. Now we want to solve for x. So we can make x the subject. We send this x across because it's already negative. It becomes positive. Then we bring this 12,500 on this side. It becomes negative 12,500. So 13,300 minus 12,500. 12,500. Now we get the 0, this 13 I want to is 13 minus 5 is just 8. So we have 800 students or 800 applicants who pass both the English and the math. Now, since we know that 800 persons pass both the English and the math, now they're asking us to find how many persons pass only math. So this is only math. So only math now should just be 3,600 minus x. And what is x? X is 800. So you subtract 800 from here, you get 2,800, right? Only English. So only English we have 4,500 minus x. So 4,500. X now is 800. 800 students pass both English and math. So you subtract this from here, you have 3,700. So you notice that if you add all of them, this one is 2,800. This is 3,700. This is 800. And this side is 5,200. If you add all of them, this is 800, 3,007 plus 800 plus 2,800 plus 5,200. It should just give you 12,500. So this is 0, 0. Now this is 8 and 8 is 16, 16, 17, 18, 20, 25, 25, you carry the 2, and then 2 plus 3 is 5. It's 5, sorry, this is 5 plus this 5 is 10, 10 plus this 2 is 12. So it's 12,500. So lastly, we saw this problem. So, it says a survey of 450 patients conducted at the John F. Kennedy Hospital showed that the following results was received. One, we had 300 patients with malaria, 180 with diarrhea, 80 patients had both malaria and diarrhea. Illustrate the Venn diagram. Illustrate this problem in the Venn diagram. How many patients had none of the diseases? And we solve the other two problems that we included. So the first thing, again, we collect our data representing what we were asked for with some unknown variables. So we say, since we have malaria and diarrhea, let's say our M equals to malaria and our D equals to diarrhea. So anyway, we see malaria now we refer to that as M and diarrhea we refer to it as D. So the next thing we know is that 450 patients, the survey was conducted among 450 patients. So that is a universal set, which is number of U equals to 450. And secondly, it said 300 patients have malaria. So the number of persons with malaria is equal to 300. The number of persons with diarrhea, number of patients with diarrhea is equal to 180. And also 80 patients had both malaria and diarrhea. So it means the intersection, right? The number of patients with malaria intersect diarrhea is equal to 80. So how many patients had none? So none are those people outside of the two sets. So it's M union D or prime is equal to some unknown variable X. So let's illustrate this in a Venn diagram. So if we sketch a Venn diagram and have 2 cycles in this Venn diagram. So we know that U now, number of U is equal to 450. And malaria, so we say let this side equal to malaria, which is 300. And let this side equal to diarrhea, which is 180. And we also notice that 80 students or 80 patients had both malaria and diarrhea. So 80 right in the center here. 80 right here. 80 patients have both malaria and diarrhea. So to know how many persons have only malaria now is just 300 minus 80, which is 220. This is 180 minus 80, which is just 100. So 100 patients have only diarrhea. 220 patients have only malaria. Now, what's about patients that do not have malaria and diarrhea? That is question mark. We do not know. So we find the number of patients without malaria, neither diarrhea. So again, region 1 plus region 2 plus region 3 plus region 4. So region 1 plus region 2 plus region 3 plus region 4 all equals to the universal set. So region 1 is 220, region 2 is 80, region 3 is 100, region 4 is x, all equal to 450. So now we add these 3. This is 220 plus 80 is 300 plus 100 is 400 plus x equals to 450. So we solve for x and send this 400 across. So it's 450 minus 400. So x now becomes 50. So we have 50 patients who never had the malaria and that of the diarrhea. So thanks ever so much for our class. See you next class.